So the work cycle programs itself have some features that we must take into account for the to be used for the operation of the automated system. First of all is the number of steps in the work cycle. How many distinct steps or work elements are included in the work cycle? Okay, so we can see that the sequence is load, process, and unload. So the steps in each of the sections must be distinguished. Okay. Second one is the manual participation in the work cycle. Is a human worker required to perform certain steps, or is it fully automated? The third one is process parameters. How many process parameters must be controlled during each step? Are the process parameters continuous or discrete? How are the process parameters actuated? Do the parameters need to be changed during the first step, for example? And so this is one of the things that we must look into, okay, for to decide on the program work cycles. The fourth one is operator interaction. Okay, so whether the operator is required to enter processing data in each work cycle or not. The fifth one is variation in part or product styles. Okay, so whether or not the work units is identical each cycle, as in mass production or batch production, or are different part of product styles processed each cycle. Okay, so the different part of product styles is usually when we look into a flexible automation, and we know that at the end the end product is kind of different depending on the variation that happens during each of the process steps. And finally is the variation in starting work unit. So variations can occur in starting dimension or material. So if it is significant, some adjustment may be required in the work cycle. Okay, so the third element in automated production system is the control system. So the control element of the automated system executes the program of instruction. So it causes a process to accomplish its defined function, carry out some manufacturing operation, and therefore can be basically divided into two, which is known as a closed loop or open loop. So I think a lot of you have already known this beforehand. We have two types of control system, which is as you can see in the slide here, I'm looking at the example of control loop of a dryer. So you have a drying process itself, the cloth, okay, and you have the actuator, which is the heating elements, and you have a controller, okay, as well as in a closed loop you have a feedback sensor. So there are basically 6 elements in a closed loop system, where you have input, process, output, feedback sensor, controller, and actuator. So input parameter often referred as a set point, which is represents the desired value of the output. So for example, in the case of a dryer, you're looking at whether this is completely dry or iron dry, or simply foldable dry. Okay, so in a home temperature control of the process is the operation or function being controlled. So basically it is the output variable that is being controlled in the loop. Okay, so the sensor actually refers to the tool or the sensors refers to the tool to measure the output variable and close the loop between the input and output. Okay, so in contrast to the closed loop control system, an open loop control system operates without the feedback loop. So in this case, we can see that we have a timer, okay, which means that we don't really get the feedback on how dry the cloth is, but we just simply set how long it should be drying. Alright, So open loop systems are usually appropriate when the actions performed by the control system is simple, the actuating function itself is very reliable, and any reaction forces opposing the actuator are small enough to have no effect on the actuation. So in this case, the timer itself, if we cannot really have the output that we exactly want, but if you, for example, have dried your clothes long enough, then you basically know that jeans will require more time to be dry, and garments that are delicate requires less time to be dry. But this is done through you or through the operator rather than in a by using a feedback sensor. So basically in this the decision to decide whether to use an open loop or closed loop control system will actually depend on the risk. Okay, so with an open loop system, there is always the risk that the actuator, okay, so in this case the heating elements itself, will not have the intended effect on the process, and basically this will always be the disadvantage of a open loop system. Okay, but the advantage is obviously it's generally simpler and less expensive than a closed loop system. So if you're looking at to buy a dryer, if you have like very simple control system where there is no intelligence of verifying how dry the clothes are, then you basically are looking at the cheaper option. Okay, the higher end drying machines are focuses on to determine how dry the cloth is, or the ambient temperature inside the ambient temperature as well as the humidity inside the machines itself, to make sure that the clothes are completely dry. Okay, so what I want you to do during this lecture is to think of one example of automated system in appliances or in operations that you have encountered in your life, and try to provide some details on these three elements of automated system. Okay, so that includes, you need to list down on what are the required power for the process, for the programming and control, what are the control system of the appliances, and what are the program of instructions that are probable inside that machine. Okay, so